Welcome back to my channel. In this lecture, we will learn the advantages of negative feedback. Before that, we will derive the gain expression for both positive feedback and negative feedback circuit. Let us start from positive feedback. This is a circuit. Your input is Vin, output is V0. The feedback factor is beta. So beta times V0 is fed back to input. So in feedback we have beta V0. Beta times V0 is fed back to the input, and it is a positive feedback, so it gets added with the input. So here you get Vin plus beta V0. Now this Vin plus beta V0 is applied at the input of the operational amplifier. You know that V0 is equal to A times Vin. A is the open loop gain and Vn is the input of the operational amplifier. But here with feedback, your input is changed to Vn plus beta V0. So you have to include the feedback signal also. So now replace this Vn by Vn plus beta V0. Right? So next you get A Vn plus A times beta V0. Bring this V0 term into left side. Now you get V0 minus A times beta V0, that is equal to A times Vn. So next, if you simplify this, you get V0 multiplied with 1 minus A beta, that is equal to A times Vn. We are going to calculate the feedback gain. Gain is output by input. So V0 by Vn is equal to A by 1 minus A beta. So with feedback, the gain is A by 1 minus A beta. This is for positive feedback. Next, negative feedback. Here also A is the open loop gain and beta is the feedback factor. Input Vin, output V0. So beta times V0 is fed back to input. It is a negative feedback, and this feedback signal opposes the input, so it gets subtracted from the input. You get Vin minus beta V0 here. So next, V0 is equal to A times Vin. Vin, that is equal to Vin minus beta V0. So replace this Vin by Vin minus beta V0. Next you get A Vin minus A beta V0. Next, bring this V0 into left side. You get V0 plus A beta V0 is equal to A Vn. Next, rearranging this term, you get 1 plus A beta V0 is equal to A Vn. We are calculating gain, so that is output by input. V0 by Vn is equal to A by 1 plus A beta. So this is for negative feedback. So in negative feedback, already we have seen that it decreases the output and it stabilizes the output. So let us check that. In negative feedback, with feedback, the gain is AF is equal to A by 1 plus A beta. Let us take one example. A is equal to 10 power 5 and beta is 0.01. Then the gain with feedback is almost 99.9. If this open loop gain is increased to 1,50,000 with the same beta value, the feedback gain is 99.93. If this gain is decreased to 50,000 and with the same beta, your closed loop gain is 99.8. Here the open loop gain changes by plus or minus 50%. The closed loop gain of the negative feedback amplifier remains almost stable because there is no drastic change in the closed loop gain, even though there is a plus or minus 50% change in the open loop gain. Next, we will list the reason why we prefer negative feedback. First, it decreases the gain. So closed loop gain of negative feedback is equal to A by 1 plus A beta. So it decreases the gain by a factor 1 plus A beta, thereby it stabilizes the output. Second one, it increases bandwidth. Bandwidth which decide the operating range of frequency. So it increases the bandwidth. And in amplifier, the bandwidth and gain product is constant. So bandwidth is inversely proportional to gain. Here gain decreases, so definitely the bandwidth increases. And this is for positive feedback and this one is for negative feedback. In positive feedback, gain increases, so bandwidth decreases. But in negative feedback, gain decreases, so bandwidth is increases. So next one, it stabilizes the output and it increases the input impedance and decrease the output impedance. So that's all about positive feedback and negative feedback. In my next lecture, we will see what is virtual ground and virtual short. Thank you for